Okay, hello everyone. Good evening. Okay, wait for a few minutes. Okay, let's start the session. The photovoltaic system, it means a PV system used to drive a different type of loads like our home apparatus, motors, lightning, pumping, all of things. You can drive from the PV panel, the solar system. But a solar system, a PV panel, there is a panel with output power, current. The IV characteristic of this is like that only. So the VOC will be ISA. It means if you reduce the current, uh, yeah, then voltage will be increases, and if you increase the current like that, if you increase current from here to here, it means the voltage will be decreases continuously. But the all operators have a voltage rating is unlimited, in a range only. That to drive that load to any load, you should maintain the DC voltage. To maintain the DC voltage, you should use the converter type to convert, yeah, to control the desired output voltage from any input voltage. Like a input voltage will varies from, if suppose PV panel have 100 volt, 10 ampere, then but your operators needs a 220 volt like that, AC or DC both. If a DC is there, then you use simply DC converter to step up the same 100 voltage to 220 voltage and maintain 220 voltage continuously, constant, by fluctuating the input voltage. Input voltage may be varies. It's depending on the sunlight or insolation of this areas of sun. But in AC cases, you should use the inverter. But in an inverter, you will not we can't use the inverter directly. You uses a inverter with a DC converter like a boost converter to step up the voltage. Then after you use the inverter to convert the AC voltage to the DC voltage to the AC voltage. And sometime we connect the grid also, and sometime you have to charge the battery storage system. And you can charge the battery, or you can store the power to store the energy from the PV panel from the solar cell. By using same thing, you should use the converter to store the energy also. It means for the from the PV panel you should use a power converter. Then you can drive the load, AC load or DC load. Same thing you can store it also, or you can use this as the load for this. Then you use the storage system also. Storage system like a battery. In battery you can store directly DC voltage. PV source also gives the DC voltage. Many type of storage like a hydro system also come flywheel storage, but there is a bulky to store the energy. Hydro storage means you should use the pump when the sunlight is there to drive the pump, and pump store the water some levels of some up level like reservoir. Then after you use that water for the, to water turbine, use the water turbine to convert the hydro water to the electrical. Same thing. But for a PV panel have a structure, and you build a structure and keep at the surface of the earth, uh, in a position like that. If this is the solar panel, but sun is varies from sunrise to sunset. Is the varies the angle, but the solar panel have a fix. If you fix the solar panel at a point, then what is the maximum power can taken from the sunlight or from the PV panel is depending on the angle of also. What the angle of irradiation angle? What is the irradiation angle? Suppose this is the 90 degree, exact 90 degree of the panel, and insulation is like that. Irradiance of sunlight in the some angle like a theta. The insulation is not same as the insulation. Sorry, insulation not isolation. Isolation L. It should be I, and some angle of deflection also cos theta. It is depending on the theta also. If theta is 0 degree, it means the this line is exactly on this, and cos 0 is equal to 1, and it means the maximum irradiance is occurs on the PV panel plate. But if there is some angle difference, then the overall overall insulation is be reduces. Then you can say the efficiency of the panel is output voltage upon input voltage. Output voltage is same as maximum voltage as the maximum power and current at the maximum power point. Then insulation into area, because of the isolation, isolation is a kilowatt per meter square and area in meter square. We can say overall is a kilowatt. Then this insulation depending on the angle of the irradiance. Li cos theta into area. There are many points which will affect the irradiance of the sunlight on the earth and to generate the electricity from solar panel. Because of the in sunlight, you know about the there is a varied wavelength of the sunlight, ultraviolet, infrared and visual sunlight. It's depending on the wavelength. Wavelength means you know about us any signal like t, magnitude versus time. Then what is the peak to peak time? This is denoted as the time period. But a sunlight, the light have some velocity. If a velocity is there, then we can't be say that time period is on peak to peak wave. Then same peak to peak is known as the wavelength, which is denoted to the lambda. And this is denoted to the time period capital T, where the lambda is equal to, we know time is equal to 1 by frequency, but there is lambda is equal to velocity divided by frequency, because of velocity is there. This one will be frequency. Then the irradiance of the sunlight have many variation in wavelength. Some of the wavelength, some of the spectrum have a very high frequency, some of the very low frequency. Then we can't be measure this one, and we can't be measure the high frequency also. The power will be converted from PV to the electrical energy. It will be between only the visual wavelength criteria. It will be depending same wavelength. If you increases like that, then some is the normal wavelength, then this will be the high frequency. From here to here, this will be the visual frequency, this will be the very low frequency. You can say this is the medium frequency range. This is known as the ultraviolet irradiance spectrum. This will be known as the infrared. This section only known as the visual wave irradiance, and electricity produced between them only at a visual point. Its range is approximately 400 nanometer. Wavelength is measured in meters, a nanometer, a meter like that, which will be time period is measured in second. This will be the nanometer, 400 to 700 approximately nanometer. Even more than 700 is going to the infrared, less than 400 nanometer, it means a very high frequency known as the ultraviolet rays. You know about that thing. The power will be converted from electrical energy solar to the electrical only in visible range, 400 nanometer to the 700 nanometer, which is known as the spectral irradiance. Light spectral irradiance is known as the PS. It is measured in kilowatt per meter square per unit length, per unit wavelength. If you want to calculate the overall insulation L, then simply you integrate this one because of the per unit wavelength. Then you should integrate between this one to this one for calculating the visible insulation. But here is the very less energy conversion insulation. This is also very less. But if you want to measure the combined insulation of this one insulation, then you should integrate this one spectral irradiance for whole light with respect to the wavelength, because of there is a wavelength. You know, this will be in kilowatt meter square per unit wavelength. This will be wavelength will be cancelled out, then this will be in kilowatt per meter square. This is also varies. This is varies the light. It is effect of the light only. Light spectrum from ultraviolet to the infrared. But it is also performance also decreases with insulation with the day timing. You can say morning to the evening. There is also a factor. So this is the factor to affect the insulation of the light. You can say like it will be simply like this one 8 a.m. to 6 p.m. How can say this is 6 a.m. to 6 p.m. 12 hours. This is the range which this will be the 12 p.m. Any hour you can take. This one is the hour which one converted to the maximum insulation. If you want to estimate the overall insulation, then you have to integrate this one from here to here 0 to h of insulation of this one before. But I will return some simply because of this one direct multiplication of the h to taken as the square wave for measure calculate the approximately this one, because of this line is known as the one standard line 1 kilowatt per meter square. If you this is the 1 kilowatt per meter square multiplication of the h hour, then you can calculate the energy, total energy 1 kilowatt per meter square into h. It will be the total energy like 1 kilowatt h. I have written as the maximum h kilowatt hour per meter square, some value h. Because of power into time is equal to energy. The time is the in hours. This will be kilowatt hour per meter square. But some another factor also there to affect the insulation of the sun is known as the time uh, incidence angle and latitude longitude like that, and declination angle, what hour angle, what is the daytime 6 a.m. morning or noon or 2 p.m. like that. Declination angle depending on the year time of the year, what is the time like what is the it will be varies from the angle like to 30, 23.5 to minus 2 plus 23.5. It's depending on the year wise where the sun is moves on the earth coordinate system. Simply I just explain you, this is the sun. Sun is move in the ellipse form like that. The sun is here, earth is rotated from west to east. Suppose this is the earth. Sorry. It will be tilted at 23 degree, 23.5 degree tilted, this one. This is the maximum irradiance here, insolation. It will be 1.41 kilowatt per meter square. It will be occurs in winter side, because of the in winter sun is earth is rotated, but the sun is very nearer to the earth. Then the earth lighting point is like that. If you see, this area is very less. You rotate this one, the night time is very high and daytime is very less in this system. That's why this is the winter system, and sun is very nearer to this one. That's why the maximum insolation is there. Another point is this one. This point is known as the equinox line. If earth is here, then it will be the insolation is will be 1.38 kilowatt per meter square. The earth is rotated like that. And then next is if I've taken as the 3 month of this one. This is the December time. This will be March, June. This is the September time. If the earth is here, then this at this point 1.33 kilowatt per meter square insolation, and at this point this will be same 1.38. This will also 1.38 like that. Approximate this one, I think 36 kilowatt per meter square. This will be September. It means the insolation of the sunlight they also varies depending on the day of the year. Day of the year, it means what a day is define the declination angle. What is the angle? Which one? What is the insolation occurs on the solar panel or earth, you can say. It will varies from 0 to 23 degree in positive and negative way, you can say. Simple, you can say this is the earth. This will be equinox line. This will be tropic of the Capricorn. This will be a tropic of Cancer. This angle is the 23.5 degree. So 23.5 degree. This will be also 23.53 degree. It means sun is varies from here to here only. Oof. At equinox, it will be the same equinox line. This one, March and September here. And these two are December and June. It is same date, I think 21st June, 21st December. The maximum declination angle is 21st December. maximum declination angle is 23.5 degree. It will be calculated from a simple formula 23.45 into sine 2 pi n minus 80 divided by say 360. You can calculate the where n is the number of day. From 1 to 365. This is declination angle which will affect the insulation of the PV panel or PV cells, which one occurs on PV cell. This angle, if this angle is the 0 degree, it means at equinox then the maximum insulation you can get from the PV and you can get the maximum power from the PV panel. And at the declination angle is maximum 23.5 degree, then you will get the minimum power from the PV panel. Same thing. It means it will varies and depending on the day of the year, which one day like March, September, or December or June. Another thing is depending on the time of a day also. Time of the day it will be noon or 2 p.m. or 3 p.m. as morning is also affected the power of the PV panel. It will be calculated as the watt hour angle. It will simply you can calculate in coordinate system, x y z coordinate system, like that, like a spherical coordinate, but for the earth also this is not exact spherical, but you can assume this one. And we suppose this will be earth. If we take a cross section of this one to see the exact center point of the earth, this will be a center point of the earth. To calculate the declination angle, this will be this will be sunlight. At this plane is known as equator plane. The angle from equator plane to the sunlight is known as the declination angle only. The simple formula. But this sun is this will be rotated from west to east, and this sunlight is varies from here to here, like that only, started from here to here, like that. This declination angle, it will be goes to 23.5 is maximum. Suppose any point, because of the earth is tilted at 23.5 degree, it will be maximum. Then the what is the hour angle? Hour angle, it means depending on the day, hour, what is the time at a day, and this will varies from here to here. This sunlight is varies from here to here only, like that. Suppose there is a ball, like that. This is point is Z, equator point. Why? Then insolation is varies from here to here, and the watt hour is varies from here to here because of the sunlight is going here to here, east to west, and because of the earth is rotated from west to earth. But a meridian line will take uh, 90 degree to the equator plane, some of the meridian line there. I explain you what is the meridian line. Mm, this axis is from the meridian line known as the watt hour angle. Because of this will be changes. This is the this line. This meridian line is this line is known as this line. This line will be changes every time, but it will take an axis, any axis. It will be the above to the earth. Then this will line, if this line this angle is different, sun is that line, then this will be angle is different. That's why this is known as a watt hour angle. It will from evening to morning to evening. It depending on the morning to evening. And this angle is the known as declination angle. Declination angle is while by the day of the year. Watt hour hour angle is known as the time of the day. Vary from this one, the which time is the in which time and which day it will be the maximum. Like that you can calculate from this one. Okay. I just explain axis what where you can how you can calculate this one by simple way. This is depending on the center of the earth. I reduce the size of this. This thing occurs at the center of the earth only. Suppose all of thing is center at the center of earth. And suppose this is the insulation, then what is the actual insulation or effective insulation. To take this one as the equator plane, this is the half of the earth, you can say. This is the center of the earth, and this line is known as the same thing, meridional axis. You know about the AM PM timing, the same thing is timing. Then what is the AM and PM? Anti-meridian or and post meridian? It means before the noon and after the noon. Same thing, meridian line is the middle of the day line. Same, this line is same as the, if you earth is there, then the middle of that line, it is known as the meridional line. But I do presented this one is the z polar axis. You can say this one the polar axis, not a z. This is the polar axis, which is the pole of the earth. There is two poles, the north. Here is the south pole. I will taken as the north pole is the polar axis. There is the south pole. This is the equatorial line. The meridian line is same. Then this is the top of the earth. If sunlight is at, at this point, this it means the what our angle will be 0 at a noon, a meridian axis, at the meridian axis. And at the morning time, it will be a maximum maybe 90 degree, and at the sunrise and sunset, it may be same sunrise to sunset, because of the meridian line is the middle of the earth line, you can say, whichever the sun is rotated. Sun is, if earth, suppose earth is the constant and sun is going from here to here, because of the it will rotate it from west to side, then what is the sun goes from east to west, like that. If morning is here, evening is here, then what is the meridian line of this one is the middle of this one, it will be like a straight of the earth, you can say. This is the meridian line, meridional axis, the total plane. Then this line, what is the sun scatter, I have sunlight is occurring, this will be the same at a point of equator plane. If you take this is the cutting of this one half of the equator plane, I take this one, then you can understand easily. This is the half of the plane, this is the same as the same axis, same line, this one also the same point to the plane of this one, like that, same thing it will also. I measure from the here to here, this will be the declination angle, and set the point of declination angle, what is the what our angle is depending on the same projection of this one at that point, this will be known as the watt hour angle. Simply you know, you suppose this is the insolation and sunlight L at the plane, surface plane of the earth, equator plane, to make a angle, a declination angle of delta, and that same point, if a projection of this one and the surface of the earth, it will be like that, then this angle known as the watt hour angle, it will be varies from here to here, is this point to this point, it will varies from here to here. Then what is the insolation angle if you want to calculate? But all of thing is occurring on the, this will be the center of the earth. What is effect on the center of the earth? This will be related at the day of the year. This will be related the time of the day. But solar panel is placing on the surface of the earth, not the center of the earth. Then suppose solar panel is placed here, and sunlight is occurring on that plane. Suppose same thing I have taken same. This will be same. I could taken another center point of any. This is a simple plane of this one, which is earth, and some of the insolation is occurring at some angle delta. Oh, sorry, at the zenith angle. This is the sorry polar angle. This is the pole of the Earth. Same things, North Pole, South Pole. This will be the north. Downside is the South Pole. This will be same as the east, we can say, and this will be the south. East. Then there is a three quadrant system. There is also this will be the east. Downside taken as the south. Downside of the Earth is the south on the surface, and an angle as line which one taken from the center of the Earth, like then this will known as the zenith axis. If this will be a same as the zenith axis, if then the zenith angle will be 0. If a zenith angle 0, it means the maximum insolation will be occurs on the solar plane, solar plate. So the angle between this one is known as zenith angle theta z. Okay, I think you can have confused this one. I draw this one same thing here. A simple I want to draw a coordinator system also. Coordinate system. Like this will be the east. This will be the zenith angle axis z. This will be the south. East and south both are on the earth, and zenith is the top of the earth. It means on which one may meet to the center point also of the center point earth, from center to the top of the earth. If you take a line, the straight line from earth to the top of the earth, this will be known as the zenith axis. South, you know about south is the downside, or east will be east side. Then this will be looks like only same thing, spherical coordinate system. If you take an insulation of this one L, the zenith angle is from the top of the earth to the insulation angle theta z. At noon you can say the zenith angle will be minimum at noon, or can say 0 can't be say because of the depending on the day of the year also, because of every day the top of the angle will be not a 0, because it not possible to every day sunlight is the same top of the same thing. If you walking on the street, then you can see the or shadow is depending on deciding to the zenith angle. If the shadow is 0, then that day it means the zenith angle will be 0, because of you also placing on the surface of the earth also. Same as like a solar PV panel. Then this will be the angle at the top of the earth, and this will be also above the earth. This will be also above the earth. Then you should place this same thing, or you can take a projection of the sunlight to the surface of the earth. If you take this will be the surface of the earth, then what the projection of this one on the earth? take a line. Same, you can say this is the L dash, projection of the sunlight on the surface of the earth. The angle between E and south and west, south and east will be 90 degree, you know. Then this angle known as the watt hour angle. Oh sorry, not a watt hour angle, sorry for this one, azimuth angle, known as azimuth angle. Watt hour angle is same as in the equator plane, but is this the hori horizon plane? This will be horizon plane, not a equatorial plane. Equatorial plane on the center of the earth. This will be the horizon plane, it means the top of the surface of the earth. This is known as the gamma s. Then you can say the insulation is the every point. This will be the Le, this will be Lz, this will be the Ls. Then what is the L? Same as Ls plus Le plus Lz. What is the Ls? The projection of the insulation line to the south plane, the south axis. Then how can calculate the south axis plane? It will be the same thing, L dash. You know angle of this one, suppose a triangle like that, two axes x and y, and a vector is looking like that, a q vector, this angle will be theta. Then what is the x-axis and y-axis? Same as you can take a triangle like that. This will be the perpendicular, this will be base, this will be hypotenuse. Then use cos here, and what will be the cos theta? Base to the hypotenuse, this will be same as the q, will be theta. So if you confuse this one q, I can take another like s. Cos theta, it will be the base to the hypotenuse. Then what is the base? Hypotenuse into cos theta. Then base is equal to at same time s cos theta. Now I think all of you know about this. This is known as the cos theta factor. This will be the sin theta factor. This will be known as the s sin theta, and this will be the s cos theta. It will, where is the angle placed, that line, that axis is due from the cos, estimated from the cos theta. Then opposite of this one will be sin theta. Same thing you can say ls is the same angle made from the ls south axis. Then what is the ls? Ls will be the L dash, this will be the L dash, because I may taken this one L dash only. Later I measure the L dash also. L dash cos of gamma s. And what is the east? Same thing, ls to the east will be a sine L dash sine gamma s. And what is the z axis? Lz. Same thing, angle is there. Then what is the this one? Be cos. It will be L cos theta. That zenith angle. It will be L because of the it will directly make the angle from the insulation. It will be theta z. But these two coordinates not make a direct angle from theta s. That's why I've taken like that, L dash. Then what is the L dash? If this is the z, so this is the z, these two axes. These two axes on the surface of the earth only. This is the above of the earth if you take. That means the z and s have a 90 degree, and E also make a 90 degree. If you take a surface of this one to the on the the projection of this one L to the surface of the earth, then we will take this same theta. Then what is this angle made from the surface? Z will also make the 90 degree. If this is the surface, and what is the Z angle? Same as the 90 degree. And there is some insulation L. Then what is the Z surface of L dash? We take this one, L dash. What is the L dash? Same thing. This will be angle already denoted as the theta Z there. Then what is the L dash? L dash will be, you can say, L sine theta Z only, because of the Z axis, zenith axis, make a angle of 90 degree from the earth, surface of the earth, and south and east will presented on the surface of the earth only. Now first you take a projection of the insulation to the surface of the earth. It means surface of the earth make a 90 degree, and insulation is make a theta Z degree from the zenith angle. Then take a projection of the L dash. L dash will be the opposite of this one. If you make an angle, then it will be cos theta. If you not make the angle, then opposite of this one will be sin theta. That's why the L sin theta. From the trigonometry, you can say this one. This will be L sin theta Z. Same thing, we can replace here. L dash will be L sin theta Z. We can replace L dash everywhere. This will be the same. L dash will be L sin theta Z cos gamma s, L sin theta Z into cos gamma s, L cos Z theta Z. This will be the total insulation on the surface plane, surface of the earth. You can say as the horizontal plane, horizon plane, also horizon plane. But what the relation from the center of the earth? Center of the earth, same thing here, you can say insulation and the delta angle will be omega angle of meridian axis. I make a same thing here also, polar. Equatorial plane, you can say this one E, meridian axis M. Sorry, it's not arrow here because of insulation occurs from here to here. L equator plane is make from the surface of the earth will be a theta. Same thing, 3D coordinate system. Same projection occurs here. This angle will be from the surface. I measure the angle of the L insulation is from the surface only. And this angle will be what hour angle? This angle will be this angle is day of the angle, day angle you can say of the year. Same thing, this will be the LE, this will be the LP, this will be the LM. And also the L is equal to LP plus LM plus LE. Then what is the LP? LP opposite of this one. This angle is not there. Here is the theta delta angle. Then what is this one? L sin del. Simply LM. LM is equal to same thing L dash. What is the L dash? Same L cos del, because of the angle is present here. and this angle is the omega. Then what is the Lm? Lm is equal to L dash cos omega. It means the L dash will be L cos del into cos omega. Simple. La, same thing, L cos del. This angle is not present. This angle will be 90 minus omega. It will be cos. Then this will be sine omega. Then what happened if you mix this one, both axes? In a point, equatorial plane and east both are same. Equatorial axis and equinox axis and east axis both are same. Then you can see, suppose we stand from the east and see what is the looks like that. So this point is the east and equinox, the 90 degree of this one will be south. Same 90 degree of this one will be the meridian axis. This will be the polar axis. So equatorial plane it on the surface, cut the from middle of this middle of the surface earth, then you can get the equatorial plane. A 90 degree of this one is the zenith axis from south. The insulation on the south zenith axis, this will be the LZ. I measure this one also. And an angle between meridian axis to the zenith axis, because of only zenith axis is there, which one make the center point of the earth. Another axis not meeting the center point of the earth. This is center point only surface, but the zenith axis is making this angle from the center of the earth. That's why this angle known as the phi. You can say this is the longitude angle, which make from the center point, meeting from the center point, and make the angle from meridian axis to the zenith axis. Okay, if this, it means the meridian axis, this will be the phi. Then you can calculate the all of thing. We take an insulation of this one. Then you can calculate the L. Because of the insulation on zenith axis is the same, you can say the effective insulation on the solar plate, because of the normal to the solar plate is the zenith axis only. Zenith axis is the normal to the plate. It means you can say this is the 90 degree from the plate, zenith axis. Then this insulation is same as the effective insulation, because the effective insulation is the zenith axis insulation. That's why we want to calculate the zenith axis insulation. It will be what is this one? The projection of this one, meridian axis and polar axis. Suppose this is the LP, this is the LM. So what is the projection of the meridian axis insulation and the polar axis insulation to the zenith axis insulation? You want to measure from here, then what is the angle is between here? Then this will be the LM cos of phi plus of LP. This is not angle, then it will be sine phi Someone have problem, doubt, then you can ask Asutosh.
Hello, sir.
Yes, yes.
Sir, I have a doubt not regarding this particular topic,
Hmm.
but another question.
Yes.
Sir, actually, in the video lectures,
Hmm.
simulation platform is provided on the piece NG Spice,
Yes, yes.
but it is provided on the Linux operating system.
Oh, there's a problem in Windows.
Actually, sir, we nowadays nobody uses Linux operating system. So
Yes, yes, yes.
I will request ki if you can provide the Windows operating system related simulation, then that will be more better for us.
Okay, okay. We will try. Just put down a question on the or discussion panel. Same question.
Huh,
Put
huh.
there also. Then we can rectify what I will do. We can provide.
Actually, I understand ki IIT policy is to provide the open service, open source softwares. That's
Yes.
I think for that only they provide the such type of thing. But since we don't use the Linux,
Linux.
then
Yes, yes. I
uh,
understand your problem. Just put a
so
put a same question. Put on the discussion panel. Then all of
uh,
the committee will decide what we do.
okay, sir. Okay, thank you, sir. Thank you so much.
Okay. 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 Okay, the projection of the median axis insulation and polar axis insulation on the zenith axis, because of zenith axis insulation is the same as the effective insulation on the solar plate. That's why I want to calculate this one. And this will be LM. We already calculated this one. L cos del into cos omega plus LP into cos phi. LP is equal to L sin del into sin phi. Okay, simply calculate the zenith axis insulation cos del into cos omega into cos phi plus L sin del into sin phi. This is the effective insulation on the solar plate, but this insulation is the extraterrestrial insulation. You can say it is the outside of the Earth atmosphere. This insulation will be approximately constant 3.1.37 kilowatt per meter square. This is outside the Earth atmosphere, and this will be the on the plate, solar plate of the insulation. You can calculate from here. If you have the angle of the declination angle and attitude latitude angle and whatever angle, then you can calculate the actual effective insulation. Same thing if you want to calculate the daily energy. The daily energy will be from sunset to sunrise to sunset. This will be deployed like that. This will be sunrise at lit energy. And simply this insulation you can integrate from here to here, then we will get the total insulation, total effective insulation for the whole day, per day, like per day. Then what this will be the effective H naught. We want to calculate, then calculate here to here the sunset angle, hour angle. It is depending on the hour angle only, because of that it will be time. The sunset you can say S S, and sunrise you can say SR, omega SR. This will be same but in negative, because of the meridional axis is the middle of the dead point. Then the sunrise is the, if you take the omega SR, then sunset will be the minus omega SR, like that. because the meridian axis is the same as the noon time. No, the meridian x is AM PM, same thing. Omega is equal to 0 here at a noon. If you want to calculate this one, simply integrate from omega ss to the omega sr to the effective to the whole day. This will the omega is the whole day angle. If you calculate for the whole day, this will be in radian per second, kilowatt radian per meter square per day insulation, total insulation in a day. This will be same as the minus of omega sr. You know about the minus t to t, you can take just simply from 0 to t like that. So it will be omega sr, you can say Lz dw. The Lz already I will calculated this one, then you can put here and integrate of this one, then we will get the Lz is equal to L. I want to directly integrate this one 0 to omega sr. If you take omega sr, it will be omega here, then cos omega will be a sin omega, and sin omega will be a sin omega sr because of the limit integration. And this will be the cos del into cos omega sr into cos phi. Here is not any omega, then it will be all of thing is constant. It's not L because of L is common here. Sin del into sin phi, because of the constant there will be omega will be omega sr because of the limit of omega sr. This is the total. This will be in kilowatt hour, kilowatt radian per meter square per day, but we want to kilowatt hour, not a radian because of the multiplication of the angle. Sorry, you integrate the all insulation with respect to the angle. The angle will be in radian, then you have to calculate the convert the angle to the radian to the hours. Then you know pi radian, it will be 12 hour, because of a day and night mix, total is the 24 hours. They will simply take 12 hour for a day, 12 hour for a night. That's why I'm getting at pi 180 degree. If you take a 360 degree, it will be the total 24 hour. Then omega radian, it will be 12 by pi into omega hour. Same thing, you can multiply here. Then we will get the H naught into 2 L. This will be the omega. This will be the radian. Then calculate in hour. The multiplication of this one 12 by pi, 2 into 12 by pi into L 2 j cos del cos omega sr into cos pi sin pi. So kilowatt hour per meter square per day. This will be the total insulation in a day, where L is the standard insulation. Then you can simply calculate L from LSC formula from at the outside the atmosphere of the earth. It will be 1 plus, it will also depend on the day of the time, day of the year, 0.033 cos 360 n divided by of 365, where n same as the number of day of the year, number of day of the year. one for 1st January, 35 for December 31st. LLG is the standard. I think previously associated, this will be kilowatt per meter square. Standard of 1.37 kilowatt per meter square. And you can calculate the L directly by using. Then after it will be depending on the all the angle, longitude angle and zenith. Anything not there, zenith angle not, I think. Uh, Altitude angle and sunset or sunrise angle and declination angle. Okay, let's start some question, taking some question. The output of the PV cell is 2 watt at an insulation of 1 kilowatt per meter square. The area of the cell is 150 to 150 meter per mm square. Sorry, mm square. If the efficiency of the cell is 15%, then the angle of incidence of irradiation incidence of the radiation of the sunlight delta made with the normal to the solar cell. It oh The incidence of the radiation made with a normal to the solar cell. Normal to the solar cell is the zenith angle, not the declination angle. Declination angle is depending on the day of the year. It was asking about the zenith angle. Then you know L is the standard 1 kilowatt is given 1000 watt per meter square into area. The cell efficiency is given as a 15%. Area is 150 into 150 square. First calculate in meter and simply multiplication of 10 to power minus 6. Then it will be a 3.375 watt. The output is mentioned as the 2 watt. This will be 2 watt mentioned. This will be the L into cos theta z, zenith angle. Zenith axis insulation is known as L cos theta. The L is given as 3.357. It will be 2. Then what is the zenith angle? Theta z. It will be a cos inverse of 2 divided by L, 2 divided by 3.375. It will be 53.65 degree. The value of solar constant is approximately same as LSC solar constant 1.37 standard kilowatt per meter square. This will be no L is equal to ILSC 1 plus something. Then this will be the solar constant, and this L will be the this is the insulation outside the Earth. It means Earth atmosphere. And LZ, don't confuse all of the point. LSC is the solar constant. L is the insulation. Outside the Earth atmosphere. LZ is the, you can say, effective insulation to the solar plate. This will be the 1.37 kilowatt per meter square. Then after this one you can calculate this one. It will depending on the day of the year, because of the insolation of the sun is depending on the day of the year. Then angle is different thing, time. This will be calculated from the angle of zenith axis. Next will be the sensitivity of the solar cell to the spectral irradiance of sunlight is maximum at wavelength. It will be between 4 nanometer to 700 nanometer. Because of the solar radiance, it will looks like this is the wavelength in nanometer. The solar spectral radiance, PS, you can say. The 7 nanometer to 400 meter to 7 nanometer, 700 nanometer. This is the visible spectrum. This will be the infrared, and this is the ultraviolet. This will be the high frequency. This is the low frequency, high F, low F, and this will be the effective, or you can say the maximum power you can extract it here. 700 400 to the 700 nanometer wavelength. At a given point on the earth, if the solar declination is the minus 20 degree, our angle is 45 degree, and the latitude angle is the 30 degree, then the zenith angle is. Then calculate this one. First use the all of everything is given, and the LH, LZ, you know about the L cos theta to cos omega to cos phi plus sin del into sin phi. Okay, and LZ also know, you know L cos theta z, zenith angle. Then all L will be cancel out. Cos zenith angle will be the cos reclination angle into cos what hour angle, and the cos phi is the latitude. Zenith angle is given. It will be asking about the zenith angle. Cos del will be minus 20, or plus 20, cos will be same. What hour angle is given as 45 degree, cos 45, cos phi 30 degree, sin minus 20, calculate this one. Cos 20 plus cos 45, sorry, into cos 30 minus sin 20 into sin 30. It will be 0.404. And what is the theta? The cos inverse of this one. Zenith angle will be 66.144 degree. 315. At the sunrise and sunset, the zenith angle. Same thing. I have mentionality east point. So the meridional axis between of this one. Meridional is the middle of the angle, middle of the earth rotation, you can say. Then from here to here, if you take this with the meridional axis, and this middle of this one, they both are the same, but you want to calculate maximum. It is saying as the what sunrise and sunset is the same than the zenith angle. I think it's also. Sunset and sunrise will be same at what zenith angle. So, you know the zenith angle is the top of this one. Same thing if you have 90-degree zenith angle, it means 0 side O. At that day you can see the sunrise and sunset at the same time. That's why this will be the same angle, sunset and sunrise. Sorry, I think it will ask me some other thing. If both are the same, then but it's asking about the at the sunrise and sunset. Then what is the zenith angle? Sorry for this one. That phenomena occurs at the zenith angle 0 degree, not the 90 degree. You know the rise is here east, and this is the west. Take insolation of this one L. At the sunrise and sunset, the insolation will be a maximum. Sorry, minimum. Sunset insolation will be minimum. Then it means there is a plate, and zenith axis is the top of the plate. Then at a sunrise and sunset, the angle insolation will be 0. It means the maximum insolation should be goes to the this type of a 90 degree of zenith angle. Same thing if this is the sunrise and this will be the sunset. At a sunrise and sunset, the maximum zenith angle will be a 90 degree, because of at a sunrise and sunset the insolation will be 0. You know the Lz is equal to L cos theta z, then L will be 0 at a time of sunset and sunrise because of the sun is not available. Then in then this will be the angle will be 90 degree. Okay. The next question is that the length of the day will be approximately 12 hours on. Length of the day will be approximately 12 hours. It means it will be same as the sunrise and sunset. Angle will be same. It means the 12 hours night, 12 hours day. We know sunset and sunrise theta z is equal to 90 degree, and Lz will be 0, 0 insolation. And you know about Lz, it will be the L cos theta z cos del into cos omega cos phi plus L sin del into sin phi. Lz will be 0 at a 90 degree. And if you want to calculate the omega SR, if you take a sunrise time, a sunset time, then you can take any one. So you want to calculate this one. Okay, wait, the length of the day will be approximately 12 hours on the equator when the angle of declination is 0. This is the equator line. At the both point at the equator line, the angle is the equator line, the angle of declination will be 0, and same point you can see the sunset and sunrise is same hour angle. That's why the daytime and night time will be same at this point. No, at 21st March and 21st September. At that time, the daytime and night time will be approximately same. That's why it will asking the question. The length of the day will be approximately 12 hours. It means that 12 hours a daytime and 12 hours will be night time. That's why it will be at the equator. And when the declination angle will be 0 degree. When angle will be declination it will be minus plus minus 23 degree, it means this will be here and here, then this will be not a same day and night time. There will be different. Only equator plane have a same degree, uh, daytime and night time. The solar declination is the 23.5 degree and latitude angle is 45 degree. Then the sunrise hour angle in degree. Declination angle is given 23.5 degree and latitude is angle is phi is 45 degree, and sunrise hour angle is asking about omega SR. Then how to calculate the omega SR? You know Lz is equal to L cos of zenith angle axis cos del into cos omega into cos phi L sin del into sin phi. It's asking about the sunrise hour angle. At the sunrise and sunset, you know about the zenith angle will be theta z is equal to 90 degree, and this will be given latitude angle 45 degree. What hour angle is asking? Phi angle also given 23.5. This will be a 45 degree. Same thing here also. L will cancel out. Will be 0. Cos of, first calculate this one, then after we calculate the omega SR. Cos del into cos omega. Sunrise and sunset omega SR you can say to cos phi plus sin del into sin phi. Then what is the cos of omega SR? It will go into the negative minus of sine theta into sine phi. This will be the multiplication, then go into the divide of this one, cos del into cos phi. This will be the minus of tan del. Then what is the angle of omega SR? It will be a cos inverse of minus tan del into tan phi. Del is given as 23.5 degree, phi is 45 degree, tan 45 is 1, tan del is 23.5 minus of 23.5 is minus 0.4348. Cos inverse of this one will be a 115 degrees. You can see here the sunrise angle, it will be 15 degree at 23.5 degree sun angle. But when this will be a 0 degree, then we can calculate this will be, I think, approximately of 90 degree. It depends on altitude also, but it will be approximate of 90 degree. Sorry. He's asking about the extraterrestrial insolation on, it means L, March 27, 1989. March 27. The L, you know, LLC 1 plus 0.033 cos of 360 n divided by of 365. Where is the number of day? You can calculate January, it will be 31 days. February, take at 28. March, it will be 27. Total, we calculate 8, 7, 15, 1, 16, 6, 3, 3, 6, 2, 8, 86. In LSC, you know about 1.37 standard kilowatt per meter square. Then you can calculate simply LSC in point. Take the n is equal to n 86. Then you will calculate all of things. It will be 1.3741 kilowatt per meter square. On which day zenith angle will be equal to the latitude angle? Zenith angle equal to the latitude angle. Zenith angle is theta z and latitude angle will be phi. So take zenith angle will be a mod of the phi minus the latitude angle and declination angle. To take a negative of this one because of the sometime delta will be negative. That's why take a zenith angle will be same. But at a noon, if you asking about the in which day zenith angle will be equal to the this angle, it means the declination angle will be 0 and declination angle with time with day, it means 21 September and March. Equator equinox plane, next line you can take equator line, March 21st March and 21st September. This will be comes from here only. this one. If this omega will be 0, then cos theta z will be same, all of things. Cos del cos phi plus sin del sin phi. It means phi minus del or del minus phi. We can take cos a cos b plus sin a sin b is equal to cos a minus cos a minus b. Cos a cos b plus sin a sin b is equal to cos a minus b. That's why it will take approximately this one. If omega angle will be 0, if you take a same daytime as at sunrise time, at peak time, if you take a peak time, noon time, at a noon, we measure this one at a noon, omega will be 0 degree at a noon. What hour? That's why the always give will have been cos of theta z is equal to cos of omega cos of phi minus del. Because of this one, you can take any one del minus phi, and because of in this equation you can take both. That's why it will be taken as a theta is equal to mod of a del phi minus del. You can take a reverse also. You can take at a noon time, same day at a noon, omega will be 0, watt hour angle will be 0. Then you can get the theta, same thing. It will be at a equinox line, like a declination angle will be 0. Next, and what are the approximately the sun will be overhead at noon at a place located on the latitude angle of 8.57. Sun will be over no, it means omega will be 0. Yeah, latitude angle we can simply calculated from formula. Latitude angle, you know, phi is simply you can calculate 23.45 n minus 80, because the another information is not given. Then you can simply calculate the latitude angle from this formula. The maximum it will be 90 degree of sine, it will be 23.45. But it asking about the at noon overhead, sun will be overhead at noon at the place located with which day. It means you have to calculate the day of the year. N phi is given 8.57. This is the angle. This is also 23.45 angle. An angle you can divide, then 2 pi of n minus 80, 65 will be sine inverse of 8.57 divided by 23.45. We will get this one. Angle cancel out, it will be the value. Then you can calculate sine. This will be they also given as the angle sine inverse something. Give some angle also, like that. Angle cancel out is with a constant value. If there is a angle and there is some is the radian, then you can't be divide like that. First to calculate convert angle in radian also. But here the all of thing, this will be the in angle, and this is also angle in degree. It's also in degree, and this all of thing in radian because of there is a 2 pi. Now calculate this one. 8.57 divided by 23.45. Cos inverse of this one will be a 21.43. Then this will be also angle, but all of things this will be the in radian. Just calculate this will be in converted to in radian. Pi will be cancelled out, and just calculate the number of n. Approximately this will be the 10173. You can say this will be 102. And what a day? Same thing. We calculate January 31, February 28, March 31. How much is this one? 90. Extra will be 102 minus 90 is will be 12. Then it will go in April of 12. No, that's why April 12 will. At that day, the sun will be the overhead at the place located on this one. Angle also given at noon, because if there is a note given this information, then you can't be say the sun will be in overhead or not. Because if the noon is given, then you can say directly calculate the latitude angle, because omega will be 0 here. A question asked to you the from the solar panel by using the BJT. A user has to design an electronic load to measure a PV module's IV characteristic. BJT is used as an electronic load. The IV characteristic of BJT is shown below. This will be the IV characteristic. This is the cutoff region. This will be saturation region, active region. This will be the active region. Maximum collector current allowed 2.5 ampere. Sorry. What is the value of minimum resistance in ohm of the base resistor RV as shown in the circuit below? Assume the VB 0.7 volt for the active and saturation region of the IV characteristic of BJT. Assume the current gain Fe of BJT is, it will be beta 100 throughout the IV characteristic of BJT. You know there is a two transistor NPN and PNP. Simple. This will be the base, emitter, collector. In PNP, same terminal, collector, base, emitter. But in NPN, current is flowing from base and collector to the emitter. It means I is equal to IC plus IB. But here current flow from the emitter to the base and collector. But current equation will be same, IB plus IC. NPN we can describe here like NPN is this will be the NPN. NPN, N is the doping of the semiconductor, you can say this is the negative and positive, like that. P and P, this will be a P, this will N, this will P. Then base to E has a PN junction. PN junction make a diode, then this will be a diode voltage of VBE here. Same thing, and N2 positive to the reverse direction, bias, there is a current not flow from reverse bias. In forward bias, there is a voltage drop. This will be the VEB. Same thing, which one is the VBE in NPN and VEB in PNP. And beta is the current gain, you know about the IC divided by of IB. Collector current to the base current. Alpha is equal to collector current to the emitter current, total current. Okay, simple. Here is also in the circuit. This is the IB, current flow like that. IC is here, and this will be the NPN transistor, because of the current is flowing from base collector to the emitter. And question asking about what's the minimum value of RB. Then you know RB resistance will be minimum when the current will be maximum. IB will be maximum. The IB when maximum, when IC is maximum, collector current is maximum. You know about IB is equal to IC divided by beta, because of the IC divided by IB is equal to beta. Therefore, this one is the maximum. Maximum current is given as 2.5 ampere. Beta will be also given 100. And what is the IB? 25 milliampere. And second option, when the current will be flowing maximum and the voltage will be maximum. Then apply the KVL here. VB also given 0.7 volt. Then you know about V source, Vs is equal to IB into RB plus this voltage 0.7 volt. IB is here, all of the know this will be 25 volt. So simply you can calculate the RB. RB is 25 minus 0.7 volt divided by 25 milliampere. Result will be in kilo ohm. It will be 0.972 kilo. But in the question ask about the in ohm, then RB in ohm is equal to 972 ohm. Okay, simple question. Simply take a maximum current of here, then in which region the maximum current is flowing here. Then you can simply calculate, all of thing is given. The PV characteristic obtained in the question 11 is on below. At what angle of the base voltage of supplied by the rectified voltage source does the PV operate at the maximum power point? And consider the minimum value of the base resistance. Okay, the maximum point, at the maximum point the current is IC will be 2 ampere. Then IC is given as 2 ampere. Then what is the IB? Remaining thing is same. Then IB is equal to IC divided by of beta. 2 divided by of 100 will be a 20 milliampere. It is asking about the what voltage supply, what the angle. This is the sine wave, half sine wave, can say. This sine wave can be presented as Vm sine omega t. This waveform. The maximum is with Vm when omega t is 90 degree. Vm will be 0 and omega t will be 0. Then you can take simply Vm is equal to Vm sine omega t, when where Vm will be 25. And same, who can take the KVL of this one. this voltage equal to this voltage drop and this voltage drop. Vs is equal to Ib into Rb plus voltage drop of 0.7 volt. Vs you can take Vm sin omega t. Vm is 25 sin omega t is equal to Ib 20 milliampere, Rb 0.972 on the sin omega t. Point 8056. Then omega t same as the angle, you can take as alpha or anything. Sine inverse of this one, the 53.66 degree. Sorry. For a solving of transistor question, take a consumption like the resistance in kilo ohm and current take in milliampere. If you take two consumptions, then you can't be confused. You never confuse in ampere and milliampere because of the in transistor current will flow in milliampere only. That's why take a milliampere and resistance take all of the calculation kilo ohm. Then if you multiply we have this one, then what is the voltage? Voltage is same as in volt. We will get the voltage in volt only. Take these two assumption to calculate the to solve the all numerical related to the transistor. Okay, everyone, thank you. I want to stop here. If you have any doubt, anyone can who can ask me.
Sir, can I ask one question, please?
Yes, 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 yes. Definitely.
Sir, actually, in the course, we are seeing that simulation lectures are also provided.
Hmm.
So, can you please guide that simulation is important from exam point of view or assignment point of view? Can you please explain?
No, simulation only for you understanding for you only. It is not about the exam type. It's only for the understanding to you. This will not
Okay, okay, thank you.
asking in the exam or in assignment. This is only lecture type of question, numerical.
Okay,
Okay.
sir, as we are working people and we have joined this course regarding our MTech course, so we are not having much time to do simulation type of work. So that's why I have
No, no, there's
asking.
no problem. Just watch the video and understand what happening there.
Okay,
Just
okay.
it only.
Thank you, sir.
Okay. There's no problem in our assignment or exam time. Okay. Any other question? Then I have stopped here. Okay. Thank you to all and have a good night.
Thank you, sir.